Thanks. Now I'm going to talk about the perspective of using burkholderia species in agriculture. And the question is it friend or enemy? This research conducted by Zohreh Nasimi, Aiping Zheng, and John Wenshin from Sichuan Agricultural University. The study performed in Sichuan Agricultural University, located in Wenjian district in Chengdu in Sichuan province in China. Bacterial strain used in this research isolated from rice plant in the tillering stage during summer 2019 and 2020 from the rice plant. Burkholderia cepacia complex is a group with high genetic versatility and adaptability. It contains at least 19 valid species belonging to the subphylum of Beta-Portobacteria, gram-negative bacilli, ubiquitous bacteria in a wide range of niches. BCC is a controversial group with a substantial impact on medicine, agriculture, and industry. Some Burkholderia species can produce a wide range of metabolites with antifungal, insecticidal, herbicidal, and antibacterial properties that can develop as an industrial product. Some members of the BCC, such as Burkholderia senocepacia, Burkholderia multivalens, Burkholderia pseudomali, can cause chronic lung and life-threatening respiratory tract infection in cystic fibrosis. Some species, such as Burkholderia gelomi, Burkholderia gladioli, and Burkholderia plantarii, are the causal agent of seedling blight and seedling and grain and sheet rot of the rice. Based on our previous study, the initial characterization of 3 isolated Burkholderia species, including Burkholderia gladioli, Burkholderia cepacia, and Burkholderia vietnamiensis, was inhibition, the mycelial growth, and sclerotia formation of Rhizoctonia solani AG1-1A. We examined the interaction of Burkholderia species with rice plant and sequenced the whole genome of the non-pathogenic Burkholderia vietnamiensis and pathogenic Burkholderia cepacia and Burkholderia gladioli to compare their genome organization and identify common and unique gene among pathogenic and non-pathogenic Burkholderia species on the rice as the same host and same ecological niche. According to the comparison of rice phyllosphere microbial community structure in the tillering stage, at the family level, Burkholderia was one of the abundant family in tolerate rice varieties. That it was significantly more abundant in the vegetative growth stage of the rice compared to the reproductive stage of the rice. Also, in a cultural dependent method, we isolated 3 Burkholderia species that have a different interaction with the plant, while all had the antifungal activity against rice sheet blight fungus Rhizoctonia solani AG1-1A. This strain, including Burkholderia vietnamiensis, strain G40-EPL2, has the plant growth promoting properties and antibacterial activity against Rhizoctonia solani. Another strain was Burkholderia cepacia, strain G40-EPLB, and Burkholderia gladioli, strain A12-EPSTM, that have a pathogenicity properties, and they can induce the hypersensitive response in tobacco leaf. Here is the dual culture of Burkholderia species with Rhizoctonia solani. And we can see the inhibition of this bacteria against mycelial growth of this fungus. And growth inhibition percentage evaluated as shown in the chart, Burkholderia vietnamiensis was the most effective species compared to the other Burkholderia species. Pathogenicity test showed that after 1 week, chlorosis and water soak symptoms appeared in the leaf, sheet, stem, and follicle. As shown in the chart, chlorosis area also was quantified. And we can see the chlorosis area in the plant treated with burkholderia gladioli and burkholderia cepacia was more significantly more than burkholderia vietnamiensis and the control plant. In addition, hypersensitive response of the tobacco leaf that was treated with 10.7 CFU per milliliter of bacterial suspension solution, Wadley post inoculation showed that burkholderia cepacia and burkholderia gladioli can cause hypersensitive response in the tobacco leaf, but burkholderia vietnamiensis cannot. The complete genome of burkholderia vietnamiensis and 2 pathogenic species, including burkholderia cepacia, burkholderia gladioli, was sequenced, analyzed, and annotated to find burkholderia vietnamiensis potential virulence factor. The gene region related to the virulence, antibiotic resistance, and antibiotic production were compared between non-pathogenic and pathogenic species. The genome analysis revealed that non-pathogenic Burkholderia vietnamiensis harbor gene are encoding oxidofangin that has the excellent potential for developing biopesticide and pharmaceutical drug while not detected in pathogenic Burkholderia species. In the non-pathogenic Burkholderia vietnamiensis, 12 genomic islands were identified, while in the pathogenic Burkholderia cepacia and Burkholderia gladioli, 14 and 15 genomic islands were identified. Considering the beneficial effect of Burkholderia vietnamiensis and potential of using that as the biofungicide, we should be sure that it is not a potential for pathogenicity in mammalian and opportunistic infection in cystic fibrosis patients. For this issue, we searched in the genome of Burkholderia vietnamiensis to find essential virulence factors such as COP3, 2020 kilodalton adhesion biosynthesis gene, SODC gene, zinc metalloprotease, melanin pigment, and VGRG5 protein. We found Burkholderia vietnamiensis does not harbor gene of essential virulence factors such as encoding COP3, VGRG protein. Nevertheless, it has some gene encoding CF-related O antigen biosynthesis. Our results suggested that regardless of the strong antimicrobial activity and plant growth promoting feature of Burkholderia vietnamiensis, it's better to avoid direct use in the agriculture. However, Burkholderia vietnamiensis strain G14 EPLE2 has the quorum quenching potential and can be used to produce quorum quenching molecule and its potential to use for the management of disease in the future. Thank you so much for your attention, and I should say thank to Agri 2022 for providing this opportunity for us to be together from all over the world. If anyone has a question, you're welcome.